Hello everyone, and welcome back to the series of tutorial in Linux. And for this tutorial, we're going to look at files permission. So on my left, I have the whiteboard, which I'm going to write out the examples on. And on my right is the terminal where I'm going to put in the commands. So right now I created a directory, and the directory is called Linux tutorial. And there is no files inside of this directory currently. It's an empty directory. So I'm going to create a file and a directory inside of that folder. So first I'm going to use the touch command to create an empty file, which is going to call test. I'm also going to use the mkdir command to create a test_dir folder. So if I do a ls here again, then I would see the test file and the test_dir folder. If you want to see the file permission in Linux, you can do ls-l and you would see the files permission for the test file and the test_dir folder. If you want to distinguish the files from the folder, the files usually start with a dash and the directories start with a D. So what we need to know with files permission, we have read, write, and execute power. And this section is going to be for users or the owner, and this section is going to be for group, and the third section is going to be for others. There's also a number that is attached to each of the permission. So for the read permission is 4, the write is 2, and the execute is 1. And it goes across the board for the other two as well. So 4, 2, 1, 4, 2, 1. And you may be wondering, okay, how did I get the 4, 2, 1? I'm going to draw a quick table to show how I get 4, 2, 1. So I'm going to start with 0, 1, 2, 3, 4, 5, 6, 7. These are the numeric numbers, and for 0 you have no permission at all. This is for permission, this is for number, and this is going to be the binary numbers. So the binary number for 0 is 0, 0, 0. And for 1, you only have execute power, and the binary number for this is 0, 0, 1. For 2, you have only write permission, and the binary number for that is 0, 1, 0. For 3, you have write and execute power, and the binary number for that is 0, 1, 1. For 4, you only have read power. The binary number for that would be 1, 0, 0. For 5, you have read and execute power. The binary number for that is 1, 0, 1. And for 6, you have read and write power, and the binary number for that is 1, 1, 0. And for 7, you have read, write, and execute power, and the binary number for that is 1, 1, 1. So this is how you get the 4. The 4 is for read, so let me change the color, and the 2 is for write, and the 1 is for execute. That's how you would get the 4, the 2, and the 1. So how do you get the numeric value for the chmod, or to modify the file? You have to add each of the values together for each user or for each group. So for the first group, which is the user, we're going to add 4 plus 2 plus 1. That's going to give 7. You do the same. 4 plus 2 plus 1 will be 7. 4 plus 2 plus 1 will be 7. 777 will be chmod equals to 777. And 777 means user, group, and others have full permission of the file, so they can read, write, and execute on that file, which this permission, a lot of people do not recommend it, and I don't recommend it myself because there is a lot of security reasons behind chmod 777. Let's do another example. Read, write, execute, read, write, execute, read, write, execute. So this is going to be user, group, and other. So if you were told to remove write permission from the group and remove execute permission for others, then it will be 4 2 1 4 2 1 4 2 1. Now you were told to remove execute power for others and write power for group. So it's going to add up to 4 plus 2 plus 1, 7. Now being as you remove write power from group, then the 2 is gone. So you're going to be left with 4 plus 1 is 5, and you removed execute power for others, so the 1 is removed, so now you end up with 6. So it's going to be chmod equals to 7 5 6, and that just simply means user have read write execute power, group has read and execute power, and others have read and write power. So for the test files, we have read and write permission, no execute permission, and that permission is for the user, which is myself, and then I have for group only read permission, so no write or execute permission, and same thing for others, only read permission, no write or execute. So let's do chmod, and the numeric value is 756 and the name of the file, and I hit enter. So if I do a ls-l one more time, then the permission for test is changed to read write execute for the user and read and execute power the group, and for others have read and write power. Let's do a couple more examples. So we have read write execute, read write execute, read write execute, and the numeric value is 4 2 1 4 2 1 4 2 1. So this is going to be user, group, and other. So you were told to remove read power from group, so it's gone, and you also want to remove read and execute power for others. The chmod values for this would be 7. You remove read power, so you also remove the 4, so this is going to be 3, and you remove read and execute power for others. We are going to remove the 4 and the 1, so we will end up with 2. So it's going to be chmod equals to 7 3 2. So that means user have read write execute power, group just only have write and execute power, and others only have write power. So now I'm going to go over to the terminal and change the test file folder to chmod 732, where users get read write execute power, group only get write and execute power, and others only get write power. Right now this is the permission for the test file, and let's change it to chmod 732 and the name of the file. So let's do a ls-l one more time, and now you can see that the permission has been changed. So this was the previous permission, and this is the current permission with chmod 732.